these questions are some of the questions that my student that wrote last batch saw in the exam. I'm bringing it up here for you to see how the question is and understand, because some of the questions that came out in day 1 still came out in day 2. So peradventure they repeat the same question again so you can know how to solve it. And if you're watching this channel for the first time, don't forget to subscribe to this channel and turn on notification to get notified each time I post videos. With no further ado, let's get right into the video. A man 1.5 meters tall is standing 3 meters in front of a pinhole camera whose distance between the hole and the screen is 0.1 meters. What is the height of the image of the man on the screen? We have the following options. Option A, 0.15 meters. Option B, 0.30 meters. Option C, 1.00 meters. Option D, 0.05 meters. Now, before we could solve this question, you must ask yourself, what is a pinhole camera? How do you sketch a pinhole camera? So let me just do a rough sketch. So let's go. Now look at it. It said a man 1.5 meters tall. So this is the height of the man. The height of this man is what? 1.5 meters, right? And he's standing 3 meters in front of a pinhole camera. So the distance of this man to where the pinhole camera is what? 3 meters. Hope you are getting it. If the distance between the hole of the pinhole and the screen is what? 0.1 meter. So this is what? The screen. Okay, now this is the distance between, see the pinhole, and this is the distance between what? The pinhole and the screen. So we have what? 0.1 meters, right? Now we're asked to find what? The height of the image of the man on the screen. So you're looking for what? The height of what? Of the image. I hope that is clear. And remember that the image formed by a pinhole camera is always inverted, in case you see it as a theory question, okay? Now we have it this way. The intersection at this point make the image to be what? Let me extend this one. Make the image to be what? Inverted. Is that clear? Alright, so we're going to use magnification to solve this particular problem. So what is the magnification? Magnification is equals to height of image over height of what? Object. Then it's equals to length of camera or distance of image from the pinhole all over the distance of object from what? The pinhole. Do you understand? Now we're looking for the height of the man. So that's the height of the image that we're looking for. So I will say this is what? HI, right? Now the height of the object, which is the man, is given as what? 1.5 meters. So this is 1.5 meters. Then this is equals to the length of the camera is what? 0.1. This is 0.1. Then the distance of the object from pinhole is what? 3. So we have what? 3. Is that clear? So what you're going to do now is to say cross multiply and we get the unknown. You say cross multiply. Therefore, the height of image is equals to 1.5 multiplied by 0.5 then divided by what? 3. Do we understand? Let's work it out to get the correct answer. By the time you multiply, you're going to have what? 0.05 what? Meters. So this is the height of the image of the man on the screen. Do we understand? So from what we've got so far, the correct option to this question is option D. Question 2. From the diagram below, the point that represents the elastic limit is the what? We have option A, Q, option B, R, option C, X, option D, T. For you to be able to choose the correct option from this diagram, you have to understand it very well, okay? Now this is under elastic properties of solid. Now this is the load, why this is what? The extension. So you must know what this point stands for, okay? This point stands for proportionality limit, okay? Why this is what? Elastic limit. This is yield point. Why this is what? Breaking point. So in case you see it, so let me just write it. This one stands for what? Is that clear? So why I'm stating all that, in case you see a similar thing, but they did not ask you to find the elastic limit, they might ask you to find another thing, okay? So you can be able to know the particular place I'm going to choose the correct answer. Now from what we've got so far, the elastic limit from this point is what? Is option B, which is R. The equation of a certain progressive transverse wave is y equals 2 sine 2 pi bracket t over 0.01 minus x over 30, where x and y are in centimeter and t is in seconds. Calculate the period of the wave. We have the following options. Option A 0.001 seconds. Option B 0.010 seconds. Option D 10.000 seconds. Option D 100.000 seconds. Now for us to solve this question, we are going to equate it with the progressive wave equation, which says that what? Y is equals to a sine bracket 2 pi ft minus 2 pi x over lambda. Okay, now we're going to equate it with this one by saying that the question is y is equals to 2 sine 2 pi then t over 0.01 minus x over 30. Okay, now what we are going to do, because since you are looking for period and period will be gotten from frequency, we are going to equate these two, right? Simply by doing what? Multiplying the bracket or multiplying this one by 2 pi, since our concentration is just on this, so that we can equate this with this one. Hope that is clear. Okay, so let's go. We say this is what? 2 pi ft is equals to 2 pi times c is going to give me what? 2 pi t over 0.01, right? Now something is common. I'll cancel 2 pi t, right? Therefore, frequency is 1 over 0.01, right? Now if you still remember that frequency is equals to 1 over what? Period. Now if frequency is 1 over period and frequency from here is 0.01, so we can say that, as simple as that, we can say that therefore our period is 0.01 seconds. Do we understand? Alright, so this is how to solve this kind of problem. Then from what we've got so far, the correct option to this question is option B. Question 4. A wheel and axle have radii 80 centimeters and 10 centimeters respectively. If the efficiency of the machine is 0.85, an applied force of 1200 to the wheel will raise a load of what? Option A 8.0 Newton. Option B 6.8 Newton. Option C 8160 Newton. Option D 9600 Newton. Now for us to solve this, let us set our parameters, okay? By saying that we have radius of wheel, that is big R, is giving us 80 centimeter. The radius of axle is giving us 10 centimeters, okay? Then the efficiency of this machine is giving us 0.85. It is not given in percent, okay? So that means when you're stating our formula, we're not going to put times 100%. All right, so now an applied force of 120 Newton. This applied force is our what? Effort. Applied force. Anything using your energy to do is what? Is your effort. So my effort is equals to 1200 Newton. What are we looking for? We're looking for what? The load. Do you understand? So we're going to do one thing before we solve. Let us get our velocity ratio, right? Because our velocity ratio of a wheel and axle is radius of wheel over radius of what? Axle, right? Now by saying that this is 80 over 10, this cancel out, right? Now this is going to be what? 8. Now there is no point of you dividing or converting to meters because they have the same unit, okay? But in a situation whereby one is in centimeter and the other one is in what? In meter, you have to convert to be in the same unit before you can find your velocity ratio. All right, let's go. So the efficiency formula, efficiency is equals to MA over what? VR. I am supposed to say times 100%, but because this my efficiency is given as what? As a decimal. So I don't need to multiply by 100%, okay? Now let's go. Let's substitute what we have. We have that the efficiency is 0.85 is equals to, what's my MA? I have to look for my MA first. Reason is because that I'm looking for, I'm going to get it from where? MA, because mechanical advantage is load to the effort. Alright, so what's my VR? I got what? My VR as what? 8. Now if this is over 1, cross multiply. If I say cross multiply, so my MA is equals to 0.85 times what? 8. Right? So let's see what we have. So I have my answer to be what? 6.8 as my mechanical advantage. Now with this, I can now get my load, which is what I'm looking for, simply by saying that what mechanical advantage is equals to the load over what effort, right? So this is my mechanical advantage. That is what 6.8 is equals to load over what 1200. So by saying cross multiply, my load will now be equals to 8160 Newton. Is that clear? And this is how to solve this kind of problem under Will and what axle. In case you repeat these questions, okay? And the correct option from what we have got so far is option C. A fixed mass of gas occupies a volume of 20 centimeter cube at a pressure of 700 millimeter mercury. Assuming that the temperature remains constant, what will be the volume of the gas at 750 millimeter mercury? We have the following options. Option A, 2.5 centimeter cube. Option B, 15.5 centimeter cube. Option C, 18.7 centimeter cube. And option D, 21.4 centimeter cube. One thing that will come to your mind is they said that temperature remains what? Constant. So which law are we going to use? Or which law are we talking about? So the law we are talking about in this context is what? Boyle's law. Hope that is clear. So the first step is for us to state our parameters by saying that what? The volume V1 is giving us 20 centimeter cube. Okay? And the pressure, which is P1, is giving us 700 millimeter mercury, right? Then we are asked to find the second volume, which is what? V2, when the second pressure is what? 750 millimeter mercury, right? So let's just apply the formula by saying that what? P1 V1 is equals to P2 V2, right? Now simply because we are making V2 the subject, we're just going to say that what? V2 is equals to P1 V1 over what? P2, right? So let's just substitute into what we have. So V2 is equals to, what's my P1? 700. I will say 700 times, my V1 is 20. Okay, divided by what? My P2 is what? 750, right? So let's see what we have. That is going to give you what? 18.7 centimeter what? Cube as my what? V2. I hope that is clear. Now from what we've got so far, the correct option to this question is option C. Question 6. In a resonance tube experiment, if the fundamental frequency of the vibrating air column is 280 Hz, what is the frequency of the third overtones? We have the following options. Option A, 70 Hz. Option B, 840 Hz. Option C, 1120 Hz. Option D, 1960 Hz. Before we could solve this, you just have to remember that a resonance tube is an example of an application of what? A closed pipe. So whatever harmonics that it is applicable to closed pipe is applicable to resonance tube. Just get that stuff. If you get what I'm saying now, you won't fail any question involving closed pipe. So let's go. Now, what are the harmonics of a closed pipe? The harmonics of a closed pipe, we have what? F naught, then 3F naught, 5F naught, 7F naught, 9F naught, and so on and so forth. Is that clear? So from the question, they gave us the fundamental frequency of 280 Hz, right? So here is what? 280 Hz. Okay? Well, what are we looking for? We're looking for what? Looking for the frequency of the third overtones. You know what is overtone? Overtones are whole number multiples of the fundamental frequency. Okay? Now, this is F naught. I cannot assume that this is my overtone. But look at it now. This is 3F naught. So this is a whole number greater than what? The fundamental frequency. That becomes my first overtone. Is that clear? Fundamental frequency cannot be assumed to be what? To be an overtone. It's just the first harmonics, right? But look at it. This is 3F naught. So because this is a whole number multiple of this fundamental frequency, so is what? 3 whole number greater than what? Fundamental frequency. So I can start counting my overtones from this second one. I hope I'm clear. So this becomes my first overtone, my second overtone, and the what? And the third overtones, right? But the question says the frequency of the third overtone. So this is what you're actually looking for. Is that clear? So what you're going to say is just third over tone is equals to 7f naught, right? Simply by saying that 7 times what? 280. Is that clear? And the answer is going to give us 1960 what? Haze. Is that clear? Now this is how to solve this kind of problem. If they say harmonics is just the serial number. This is just for a closed pipe, okay? But for open pipe is different, alright? And what we've got so far, the correct option to this question is option D. Question 7. From the diagram below, at terminal velocity, the three forces are related by the expression. We are going to use this diagram to know how these three forces are related, okay? We have the following options. Option A, V plus U equals mg. Option B, mg plus V minus U equals 0. Option C, V minus U equals mg. Option D, mg plus U equals V. Now, one thing that will come to your mind from this question is this. Upward force is equal to downward force, okay? But here we have what? The obtruse. Obtruse is always acting up, right? And because this is a viscous liquid, so it has the terminal is also acting up. But the weight of this object is acting what? Down. So what am I trying to say? That this V plus U, it will now be equal to what? Mg, right? V plus U is equals what? Mg, right? Okay, so what are we looking for? Let's see how we can relate them. Now, if you have gotten this, it's correct, okay? Now you can get from the option, which is option what? A. But you can still carry this one to the other side and equate it to 0. So let's see, by saying that V plus U minus mg is equals what? 0. Do you have any option like that? No? No other option. So this particular one is what? Correct. But if you have it in this form, you are still what? Correct. Now I want you to note something. Let's assume that you are given the upthrust, okay, to be, let me say, 5 Newton, and you're given the mass to be 2 kilograms, and G is what? 10, right? Now the question says you should do what? You should find the terminal velocity. So what are you going to say? Just to put in the values of what you have, okay, and make it what? The subject, in case you see something like that in your exam. All right. So from what you've got so far, the correct option is option what? A. Question 8. A ray of light travels from air to water. The refractive index of water is given by the expression. Option A, velocity in water over velocity in air. Option B, sine of angle of refraction over sine of angle of incidence. Option C, apparent depth over real depth. Option D, wavelength in air over wavelength in water. Now the correct option is option what? D, which is wavelength in air over wavelength in water. Question 9. The property of a body to remain at rest or to continue in a uniform motion in a straight line is called option A, momentum. Option B, inertia. Option C, impulse. Option D, energy. The correct option is what? Option B, which is what? Inertia. Question 10. A uniform beam PQ of mass 20 kg and length 5 meters is balanced as shown below. A man of weight 800 Newton stand at M such that QM equals 2 meters. The reaction at P and Q respectively are, and we are given G to be 10 meters per second square. Now we have the following options. So work it out and see the correct answer. So let's go. And the first step is that we are going to rearrange this diagram, okay? We are going to sketch this diagram by having this one. Alright, so this is what? This is a uniform bench. This is P and this is what? Q, right? And the length of this is 5 meters. So take note. But this beam, the mass of this beam is what? 20 kilograms. We're going to work with the weight of the beam. Why are we working with the weight of the beam? So you're going to be balanced at where? At the midpoint of these 5 meters. So the weight is equals to mg. That is 20 times 10 is going to give us 200 Newton. That is just the weight of the beam, okay? And it's going to be at the midpoint. That is 200 Newton, right? It's going to be at the midpoint. So from here to here is going to cover 2.5 meters. Is that clear? Alright, so let's go. A man of weight 800 Newton stand as M. So where is M? From here to here, it stands as 2 meters, right? From point what? Q. So from here, I have 2 meters. So see, this is the weight of the man. The weight of the man is 800 what? Newton. You're looking at the reaction. So the reaction at this point is acting up. Okay? Can you see it now? And remember that the distance from here to here is 2 meters. If it's 2 meters, that means here will be what? 0.5 meters. Are you following what I just did? Okay, so if here is 2 meters where the man was standing, then from here to the midpoint becomes what? 0.5, so that it can complete the 5 meters, which is the length of the beam. Is that clear? Now what you're going to do is that you're going to use the principle of moment to solve it, okay? By saying that some of the upward forces must be equal to some of what? The downward forces, okay? So let's go. Now you can see the upward forces. The upward forces are the reaction at P and what? Q. You can say that P plus Q, they are upward forces, right? Is equal to what? 200 and what? 800. So let's go. I will say that P plus Q is equals to 200 plus what? 800, right? So that is P plus Q is equals to 1000 Newton. I hope that is clear. Now the next thing I'm going to do is to say that clockwise moment equals anti-clockwise what? Moment. Because we have these 2 points, we must consider one, okay? So if we make this one our point of consideration, we are going to take the clockwise moment this way, about this point, okay? So this is clockwise moment. This is clockwise moment, right? Now this clockwise moment from here to here, the distance of this 200 is what? 2.5, okay? Then plus 800 times the distance from here to here is what? Is 0.5 plus what? 2.5, which is going to give us 3. Is that clear? Then for anti-clockwise moment is from here. You take it this way, anti-clockwise, right? That is this Q now multiplied by what? The distance from here to here, because they are considering this P, okay? So distance from here to here becomes what? 5, because I'm going to say 2 plus 0.5 plus 5 is going to give me what? 5. Do you understand? So the essence is for us to get our Q. Once we get our Q, we can put the value here to solve our P. I hope that is clear. 200 times 0. Times 2.5 plus 800. Hope you are getting it now. Times 0.5 plus this, that is going to give me what? Times 3 equals to my Q multiplied by 5. So Q times what? 5. So let's add these ones and see what we have. And this will give me 500 plus 2400 is equals to 5 what? Q. By the time I add, I'm going to have 2900, okay? 5 what? Q. Alright? Then my Q is equals to 2900 divided by what? 5. That is what? 580 Newton, right? As my Q. Now if I've gotten Q, I can now get P from here if I put the value, right? By saying that what? P is equals to 1000 minus 580 is going to give me what? 420 Newton. I hope that is clear. Now this is how to solve this kind of problem. So the correct option is what? They said at P and what? Q. So my P is 420 while my Q is what? 580. I hope that is clear. So the correct option is what? Option B. If this video was able to help someone out there, please don't forget to subscribe to this channel and turn on notifications to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this same forthcoming exam will see it and learn from there. I will see you next time in the next one. Bye for now.